Welcome to a video presentation of Chapter 4, Section 1 in McDougal Littell's 8th grade textbook entitled Factors and Prime Factorization. On the left side of the board you'll find two of the four definitions today. First one is prime number. A number greater than 1 whose only positive factors are 1 in itself. A number greater than 1 whose only positive factors are 1 in itself. As you can see, I've given you a starting list of some prime numbers there. By no means all of them. A complete list of what we know would take many, 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 many pages. You can see I've got 2, 3, 5, 7, 11, 13, 17, etc. Then we've got the definition of composite number. A composite number is a whole number greater than 1 that has positive factors other than 1 in itself. A whole number greater than 1 that has positive factors other than 1 in itself. There are many, many, many more composite numbers than there are prime numbers. All right, so let's go to example 1 and 2 where we're actually dealing with prime or composite. In examples 1 and 2, we're going to list the factors of the given number and identify if it is prime or composite. Now, this is often an area of confusion for some people because there's two different concepts that flow into chapter 4, and they're pretty similar. There's multiples. Multiples are what you get like on a times table. Like if I said to you the multiples of 3, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, so on and so forth. Those are all multiples. Factors are two numbers that multiply together to make a number. So for instance, if I said to you what are the factors of 8, okay, well, 1 and 8 would be factors of 8 because 1 times 8 is 8. And 2 and 4 would be factors of 8 because 2 times 4 also makes 8. We're talking about that concept here, factors. So, the first number we're given is 32. I have to find some factors of 32. So, for instance, 1 and 32 would be factors of 32 because 1 times 32 is 32. Give me another set of factors of 32. Kaylee.
4.
And?
8.
4 and 8 would be a good choice. 4 times 8 does make 32. Give me another set of factors of 32. Go ahead.
2.
And?
5.
I can't do it.
16. Oh, 16.
Wow, 16. Thank you. How'd you come up with that answer?
I don't know. Me.
All right. Those are all the factors of 32. Since there's numbers in the list more than 1 in itself, by definition that means this is a composite number. Okay, all these middle numbers here are basically what makes it composite. All right, so let's do the same thing with 53. Give me two numbers that multiply together to make 53. Kaylee, redeem yourself.
1 and 53.
Okay, 1 and 53. Give me another set of numbers that makes 53. Nick? Kaylee?
I think that's it.
Yes, you're correct. There are no other factors of 53. So by definition, that means this is a prime number. The only two numbers I can multiply to make 53 in a positive sense are 1 and 53. That makes it prime. Okay, let's go to the next thing we've got to do tonight. Prime factorization. Prime factorization. Writing a number as the product of its primes. Writing a number as the product of its primes. Now, for most of you, when we hear prime factorization, you should be already thinking factor trees. And that is indeed what we're going to have to do here with prime factorization. Okay, we make the factor trees, then we write out the numbers that multiply together to make the number. So, let's go through the first one there, 450. So, the first thing you've got to do is come up with two numbers that multiply together to make 450. You can use any set of numbers you wanted to. By the time you finish, you'll all have the same solution. Because I'm not a glutton for punishment, I want to get this done sometime in this millennium, I'm going to choose 45 and 10.
Why?
And for each number, you make a branch off to it, and continue on down the branch until the number is indeed prime. Now, 45 is not prime, and 10 is not prime. So I have to continue breaking each of those down. So let's go with 45. Give me two numbers that multiply together to make 45. Brian? 9 and 5 would be a good choice. We know 9 isn't prime because I can use 3's to make 9. But 5 is. The only way I can make 5 is 1 times 5. So what I like to do when I'm done with a branch, once I get a prime, I circle it. That way I don't have to go back and try to figure out, well, what numbers am I using here? It's a little bit easier to find, especially if it's a big factor tree. You should also point out, if you want to, instead of going top down with your factor tree, you can go left to right. Some people like that because the papers are lined and that's the way we read, blah, blah, blah. If you want to go that way with them, that's fine. All right, write down 9. Shelby, you can do 9. There's only one way to make 9 other than 1 and 9.
3.
And?
3.
Wow, that's a good answer. How'd you come up with that?
Smart woman.
And 3 is a prime number, so that branch is done. All right, let's go ahead and take a look at 10. 10, two numbers that make 10. Ashley?
2 and 5.
2 and 5 would be a good guess.
So
We
3.
already said that 5 is a prime number, and 2 is obviously a prime number because not much trick here. 1 and 2 is the only way you're going to make 2. So we're done with that.